Motion and actions in a game are very closely related with animations. So today we're going to get more familiar with animation in Unreal. So if I head over to Characters, Mannequins, Animations, there is this ABP Kin here and this ABP Mani. ABP Kin is used by the default main character, while ABP Mani is actually the parent of this. So a lot of the code from here is actually kind of taking effect here as well. So let's go ahead and open up ABP underscore Mani, and now you'll see this event graph. Now I'm just going to close this compiler results. Now the primary purpose of this event graph here is to set variables that our anim graph can actually utilize. Now these variables, for example, ground speed, show up in our essential movement data here. So it's just part of this blueprint. Let's go back up here to the anim graph. And this is actually what defines the capabilities of what animations this blueprint can play. And there's actually a lot more to this. You can see if I hover over this, it kind of shows that mini window there. If we double click it, we can now see all this stuff. And then we can do a further double click on one of these, and we can just see use cached pose here. And then we can further double click on that. So if you're wondering where something came from, you can usually double click it, and that'll help you find its source. Now, what is actually going on here is probably a question that you still have. You see how these kind of circle things are going through here? This is like, it's showing you the pass through of the information. So if I go over to locomotion here and then go to idle, this is actually the animation that's currently playing in this preview window. So I can actually open this as well by just double clicking. So this is the animation menu where you can make all kinds of adjustments to the animation, and you can add gameplay functionality at certain points. And the way to do that is by in this notifies section. If I go one step down, I can just right click, add notify, and I can have any of these things happen when this point is hit, right? So for example, if I want to play a sound, I can then click on here and then go to details and then change the sound to something that we can actually hear. Let's go with collapse 01. We can play this. However, this sound won't actually occur in our game because this animation is actually being overridden by the child blueprint that I mentioned before. So unless we switch our animation blueprint over to Mani Anim BP, this won't actually play in game. If we want this to play in game at frame 50, let's just delete that. We can head over to Mannequins Animations, ABP underscore kin, then go over to Window, Asset Override Editor, and just click this drop down for the anim graph, locomotion drop down, idle drop down, and if I drag this out, you can see that this is using mf underscore idle, not mm underscore idle, which was the one we opened up from here, right? So back in ABP kin, you see this little search icon. Just go ahead and click that, and let's create an anim notify by just going over to that other animation and going to frame 50 and doing the same thing that we did before. Go over to here, right click, add notify, play sound, and then switch that over to collapse 01. We can just close that and play. We are looping that animation if we are just sitting in that idle position. So yeah. So let's go back to the ABP underscore Mani, and we end up here, but we can go back to the other areas by clicking one of these. This is kind of similar to the Explorer, the File Explorer. So we can click this to go one step back. If I go back there, we can click this to go 2 steps back. So just to clarify something real quick, because our idle state is active in this preview, you can sort of think of it like this final output pose is being passed through. If we go back to the anim graph, it's being passed through here because this is the state machine that our idle state is in, right? It's being passed out of here and then into here, which is then inside here. And then we have another active state here. And this is what the cached pose is. This is just taking the information from here and then outputting it back through here. And then this output is coming out of here. Montages I'll get to. Inverse kinematics has to do with how the unit is posed based on the things that they're making contact with. And then the output pose is like what is gonna be showing in the game or in the preview. And then as for the movement, if we go back to locomotion, this transition thing here, these arrows, are basically saying like it's going to switch over from the idle state over to the walk/run state if this condition is met. So if we hover over here, you see this red boolean that says should move. If I double click on that, this is actually just a boolean that's being plugged in here, but it's basically saying like, if this is true, then we can go from here to here and therefore start walking or running. Now, if you're wondering what this is, that is the event graph that I mentioned earlier. So if we go back to the event graph, over here, you can see this should move, which is basically being determined by what our speed is, as well as what our acceleration is. And this is saying if our speed is greater than 3 centimeters per second and our acceleration is not 0, so we're accelerating at least somewhat, then we can go ahead and proceed with that transition over here, right? And then of course, if the condition is false, so if either we're not accelerating or we are not moving at 3 centimeters per second, then this is going to be false, which means that we're going to stay in the idle state, and therefore the idle animation will keep playing. Now, I sort of mentioned that in states rather than animations, but you might be able to figure out that this is like the walk-run animations, right? However, the interesting thing about this is that it's not just one animation like our idle, it's actually something called a blend space. So if we double click on this, you can see this character kind of really slowly kind of walking. This is basically like the slowest walking speed that there is. But realistically, if the character is not moving, then they're going to be in the idle state, right? So they're not even going to be using this blend space. So this graph here actually has multiple animations within it. And if you hold down the control button and then just move the mouse through here, you'll actually see that the animation changes. So basically what this is doing is, depending on a certain number, which is actually, you can see it there, it says speed 346.8. Based on that number, it's going to play a different animation, and it's actually going to like have a transition between those two. So like right here, there's actually no animation that corresponds to this because these are where the animations are in the sort of scale. And so what is deciding what to show in the game is, if we go back to ABP Mani, is the ground speed, which I talked about earlier. And then of course, if the player stops moving, so should move becomes false, then we're going to go back to the idle state. And this one's actually being overridden by ABP kin as well. It's this one here that's being used by ABP Kin. So let's actually set up one of these ourselves now. So let's just head into third person, blueprints, BP third person character. So the animation blueprint, this Anim class, is what we're currently using. So to demonstrate that, this controls all of the animations and stuff for our character, if I set that to none and then compile, now it just shows like the standard like A pose as I move around. Basically, the animations have been completely disabled since there's no Anim class. So now let's create our own. And the way to do that, let's just put it back in this other folder. The way to do that is by right-clicking here in the content browser and then going over to animation and then animation blueprint. And it's asking like which skeleton we want to use. A skeleton is kind of like the bone setup, and every skeletal mesh has a skeleton associated with it, or at least it needs to in order for it to have animations. It gets more technical, but the one that will actually work with this mesh is SK mannequin here. So just click that and then create. I'm going to rename this. Let's rename it Anim BP underscore third person. And then if we open it up, and I don't see the anim graph here, it should be, if I double click on that, yeah, there it shows up. So just a very basic setup. So let's create a blend space for this now. I'm gonna right click in here and go to animation. You see this blend space here? This actually will use two different variables rather than one. So we saw in the other one that we were just using speed to determine like which animation to be played. That one is actually in legacy Blendspace 1D, and just select the same skeleton that you're using for the Anim BP. Maybe third person blend space. And just double click on that. Now the other one was set up in a way that when the blend space is being used, the character is moving. However, if we put an idle at 0, then assuming we're using speed as our variable to control the animations, then that can actually work as well. We have idle animations in here. Like this is actually a list of like all of the different animations that will work for the skeleton that is on this blend space. So over here, mf underscore idle. So just left click and drag this over to the graph. And if you hold down shift, then it'll actually snap to these different points. So you can see 25, 50, 75, 100. If we're talking about the idle animation, we can ask ourselves the question, when do we want the idle animation to play? And the answer would be at speed 0, right? Now, by default, 100 speed is actually not the like max walk speed of the character. We go back into the third person character, and then in the character movement component, we search max walk. It's actually 500 is the max walk speed. So just to keep things simple, we are going to be using speed for this. It's very common to use speed for blend space. So the way to change this is in the asset details section on the left, in this drop down in the horizontal axis, this maximum axis value. Let's go ahead and change that to 500. And then we have like run, walk. There might be a sprint. No, there's no sprint. Okay. So when do we want this character to walk? Well, I mean, it's kind of up to you. note that animations are kind of designed for a certain speed. So like if the character is moving at like speed 500, but they're playing this walk animation, the character is going to look like they're on an escalator that's pushing them forward. And then if you set it too low, like if you set this to like speed 5 centimeters per second, then it's going to look like they're on an escalator that's pulling them backward. So there is kind of a sweet spot for this animation, and I don't know what that is. In this case, we can reference the blend space that we have, but for purposes of trying to work through the problem here, let's not do that. So when do we want this character to walk? Maybe, let's say 175. Let's try that. And then when do we want this character to run? Let's do 500 probably. And then in order to preview this, you can hold down Control and then just hover your mouse over this area and it'll change. And just to clarify something, this preview value is like if we have the speed plugged in directly to this blend space in the anim graph. This is like the value, so like it says 335 here. So like at speed 335, it's going to be showing this. So I think that's it for our blend space. In order to put it into our anim graph, we can actually just drag it in and then plug that in. And we can rename this as well in this name slot here. Let's just put in speed. There are a few ways of actually getting the speed from the character, one of which is using a property access. So this property access here. And then if we do a try get pawn owner, this will just access the character that is using this animation blueprint. So if third person character is using this animation blueprint, it's going to access this. So from here we can get movement component, and then get velocity, and get a vector length from this. So this is a whole math thing. A vector is, like in the case of velocity, it's just how fast the character is moving in the 3 directions. But from a mathematical perspective, though, a vector is like, let's say we have the vector 555. Well, that is 5 units away from the origin on the x-axis, 5 units away from the origin on the y-axis, and 5 units away from the origin on the z-axis. And in this case, just for visualization purposes, if we add an object like a sphere and then put it in 0, 0, 0, and then let's scale it down, maybe 0.1, and let's just delete this so we can actually see what we're doing. If I duplicate this and then put it on 50, 50, 50. If you were to imagine an arrow from here to here, that would basically be the vector 50, 50, 50. But of course, the vector that I'm talking about takes up an area within 3D space, right? So therefore it has a length, and that length would be the distance from here to here. So that is what this vector length is, just in centimeters. And that actually turns out to be the speed. So we can plug that in. Now, the problem with this right now is that it uses a potentially thread unsafe call. This happens when you have stuff in your anim graph like this. So one way to fix this is by going to the class settings and then going to the details and then searching thread. And you see use multi-threaded animation update. Just turn that off and then compile. and then it works. The other way is by doing what the blueprint that we were looking at earlier did, and that is to actually save this as a variable within the event graph. So let's actually do that. So I'm just gonna box select this and then Control C to copy that. Event graph. I think I'm actually gonna change some things here. I need to do a get owner, try get pawn owner, and then we can just add a variable, call it speed, and then it's going to be a float because the output of this is a float. And then we can alt drag this out and then connect that, and then back to the anim graph, compile. Let's get rid of this and just use the speed variable here, control, drag that out, and compile, and then we're done. So again, we are using our speed to determine what animation to play. So when the speed is 0 here, we're going to be idling. When the speed is 500 here, we're going to be running. And then when the speed is 175, we're going to be walking. And then of course the stuff in between. So we're basically done with our movement system. So we don't actually need a state machine. The reason that the other blueprint has like all this other stuff is because this is actually just for the movement. So like if we wanted to play something other than this for a certain scenario, then it would be good to have a state machine. And I'll actually show you the problem with this setup. First of all, we have to go back to content, third person blueprints, and then in the anim class we can add it's anim BP third person here. Yeah, so if I jump, then it just keeps playing the animation based on what the speed is, so that's not good. So to set up a jump mechanic that is actually properly playing a jump animation after jumping, you'll want to have a state machine. So let's get going with that now. Let's head over to here. So in our anim graph, we can right click and then add a state machine. So this thing will show up here. And then let's just Control X to cut that. And then just double click on this, and then we can drag off from here and then add a state. Let's just call this on ground. So we want our blend space to be used while the character is on the ground, right? So if we double click on this and then drag this in here, and then use the speed here, this will accomplish that. And now we can add another state here. This is going to be our falling state. And as for why I'm calling it falling rather than jumping, I'll show in a little bit. So this actually has a problem right now. If we go from the on ground state to the falling state, then we won't actually be able to go back to the on ground state. So these arrows can actually only go in the direction of that arrow. It can't go backwards. So in order to make it so that we can go from falling to on ground, we can just drag out another arrow from here and then connect it to there. And by the way, the area that you start from is gonna determine like the direction of the arrow. So if I start from here and then go over to here, it's gonna create a direction this way and then vice versa. So let's set that up. Right. And right now it's giving us these errors because we haven't added our transitions. Now, as far as the transitions are concerned, that's back in the event graph. Off of this get movement component, there's actually a pretty useful function called isFalling. This is going to determine whether or not we are on the ground. It says not flying, so I guess that means you would literally have to be falling like under the effect of gravity. So we can just promote this to a variable and then connect that, and then I'm just going to call it is in air. So we can use this now to determine whether or not the character is falling. So we're going to say that the character is not in the air. So using this not boolean will allow us to get the opposite of this. So like if this is true, then this is going to be false. And then if this is false, then this is going to be true. And then going back here, we're going to do just plugging this in. The default animation blueprint uses aliases to accomplish this. I'm going to use montages. So if I go back to the top of the anim graph, just like blueprints, you can alt click on these to delete them. If I right click and then either search montage or slot, you'll see the slot default slot. Just go ahead and click on that and then connect both sides. This will allow us to play montages, and I'll show you what that means. If I go over to the animations here, you see this jump here. I'm going to right click on it and then create Anim Montage, and then I'll just leave the name as the default. And I don't actually have to adjust this, but this kind of looks like the normal animation editor. This is actually just using the other animation that we created this from, or at least it is currently. Change it if we want, but any edits that we make to this will transfer over to this. The main reason that I use these is just so that I can call these animations. If I go to the blueprint and then just search play animation, this is not a good function to use unless your character is like dead. It will kind of override the entire animation blueprint from my experience. So and montage play in the animation blueprint, you can't actually access your standard animations from here. So this is the function that won't actually override the entire animation blueprint. It will actually, like, once the montage animation is done, then it will resume what it was doing before, which in our case is just going to be using the state machine. So we actually need this in order for montage play to work. I'm actually not going to use this here. I'm actually going to use this in the jump section, which is actually here. So I think if I just go get anim instance, it's not that, it's get anim instance, and then montage play. And so when the jump is triggered, we're going to play this montage. So we want to select the jump montage. So this montage to play will occur when this fires off. Stop all montages will just, if you have other montages playing when this is called, then it's gonna stop those and then play this instead. But then if this is off and then you have some other one on, then it's not gonna play this. And then you can start at a certain point during the montage that is referring to this. So 0, 0 would be right here. If I were to select like 0.3, it would be right here. I believe aside from that, the only thing we need to do is in our state machine, actually drag in our falling animation. which is this fall loop. So now we have a slightly better setup. There are some issues with it. Again, you can reference the actual one if you want to refine this further. Now, as for some more practical use cases of this, here you're seeing animation blueprints working with a combat system. And here you're seeing animation blueprints working with a climbing system.